Hi, hello everyone. I'm Andrew from 345 Technology. I'm here with my colleague Danny, and today we are just going to do a simple little bit of building a machine learning model. We're going to do the most simple bit of model building you can. So we're not going to do anything that's going to blow your hair back. We're just going to show just how easy it is and just how small the amount of code you need to write is to just build your first machine learning model. So let me just share my screen. So what we're doing this is what we're going to use today is we're going to use Azure Machine Learning Studio. So in Azure Machine Learning, we create a workspace and we have access to various things. So one of the things we have is we have notebooks. We can actually do automated machine learning, which is where you get Azure Machine Learning to choose the model for you. And you can do all sorts of things like experiments. We also have somewhere where we store our models. Now, what you'll see here is we haven't got any models because we're going to make one in a moment. So what I've got here prepared is a workbook. Now, this Azure Machine Learning workbook is actually Azure Machine Learning skins Jupyter Notebook, and Jupyter is pretty much the standard thing people use now to run machine learning using Python. And Python is rapidly becoming the language of choice for machine learning. So what this allows us to do, the thing with these notebooks is it allows us to put a bit of comments, a bit of commentary, and a bit of Python code. It allows us to do both and run them. So in terms of this demo here, I've got a notebook and it's got some code in it, and and what we're going to build is an anomaly detection model. So imagine that you've got a machine in a factory that's measuring things like pressure, temperature, humidity, and you want to have a warning when something's wrong. This is the sort of thing that we'd use an anomaly detection model for. So let's dive straight in. So what I'm going to do first, we've set this up, but as with all things with Python, you need to make sure that you've got all the Python libraries that you need. So we can run this. So every time we run this, we make sure that we've got all these Python packages already installed. Now, because I've run this already, we've already got these Python libraries installed. So those are already satisfied. So we're all good there. The next thing we need to know is that we're running this as a sort of as a live interactive program. So we need to load all the Python packages in. So there's various packages we're going to use today. So pandas is helps us work with data. NumPy helps us do maths. Pickle is something that helps us do machine learning. And we're going to use matplotlib, which helps us plot things out. So let's just make sure we've got all those packages loaded, so we're all good. So one of the things we're going to do with this is that imagine with machine learning, you need to tell a machine learning algorithm, you need to give it input data and you need to give it the answers. And you need to give it as many inputs and answers as it needs in order to train the model, in order to learn how to interpret your data. So what we've got here is we've got a data set, a CSV file of temperature and pressure data. So let's just run that, and we've called this command here to just load our temporary data. And what we've got here is we've got hundreds and hundreds of readings of machine temperature, pressure, what the ambient temperature is in the room, the humidity in the room, and we've got this extra column here, which is so these are the inputs, these 4 columns. And this anomaly column is the answer. So that's saying, is this an anomaly or not? So if it's a 0, then we're all good. It's not an anomaly. But if that's a 1, then there's something wrong there. So we can go through this data and we can say, okay, there you go, row 25. For some reason, we've got like 33 degrees here. This sort of pressure, and that's an anomaly. And then as we go through to the end, then there are other cases here that are anomalies. So that's what our data looks like. It's just four inputs. They're all readings they're all readings that come from a machine, and we're telling and we're giving it the answer as to whether that's good or not. So what we do next is with machine learning, you need to be able to test your model. So you don't just train it, you've got to be able to test it. And when you test it, that is, training is, here's the inputs, here's the answer. When you test it, you give it the inputs, it gives you the answer, and you compare that against the answer you're expecting. So actually, it's the same data that you need, or the same type of data you need for testing as you do for training. So what we typically do is we take a subset of, so we have our whole data set, and we take usually most of it, and we use that for training. Some people use 80-20, some 70-30. But in this instance, we're going to take 65% of our data, and we're going to train with that, and we're going to use 35% of it for testing. And so what that allows us to do is to make sure that we've trained the model, but also we get a feedback on that as to how accurate we think it is. So what we're going to do is, so literally we've taken our temperature data, or our temp data, and the first thing we're doing is we're splitting it into X and Y. Now, the reason for this is that our CSV has got 5 columns, and the first 4 columns are the inputs and 1 is the output. So what we're doing here is we are splitting it so that we take, so we get an array with the input data and we get an array of the output data. So, and then we're splitting that into training data. So in our case, just remember X is our inputs and Y is our outputs. So let's just run that. And okay, that's run because, and what we can do, taking that data, we can also use, Python has amazing plotting tools for data science, and we can do all sorts of plots depending on how we want to visualize that data. So we've got all these various kind of charts available to us. So using the the matplotlib. So this is just this is just so we can have a look at the type of data we're putting in. And then I've also got another plot here that just kind of shows our anomaly against temperature to see if there's anything that, I mean, you can't see any correlation here. And one of the reasons why this is useful is that if you can see clear, if you can see clear correlations in your data, you probably don't need machine learning because you can just use statistical methods. However, if you've got if you've got complex relationships between your data that you can't really get statistical methods to understand, then that's where machine learning is a really strong thing. So we've got some data, and it looks like that. So what we need to do now is we need to actually train our model. And believe it or not, this code here is all it takes to build a machine learning model. I mean, get rid of the, ignoring the comments. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 lines of code is all it takes to build a machine learning model. That is just mind-blowing. All this sort of, all the voodoo and the science fiction around machine learning, and we can do it with 8 lines of code. Now, obviously, what we've done is we've loaded in Python packages, particularly this, the pickle package, and there's one of the other ones we imported was sklearn. That's where all the hard work's done. All the hard work is already done for you because people have written all the code to build machine learning packages, and all we're doing is we're reusing them. So if so in this instance here, we're building a model called a decision tree classifier. So a decision tree is just a whole load of branches where you do if this then that, if this then that, and what we then do is we fit our training data to it. So you can see our X train and our Y train. We're fitting our training data into this classifier model, and then what we do is we run our test data through that model. So we do the score and we put our test data through it, and that gives us an accuracy. And then we print out that accuracy. Then all this bit at the end does is it's literally writing our model out to file. So actually the training is we're setting that variable 1, we're creating our decision classifier, we're fitting it, we're scoring it, and it's like, that is as small as it gets. So if we run that now, I mean, okay, this is a small data set. So we've got, so it doesn't take very long. A decent sort of cloud computer can just munch through hundreds of rows in no time at all. But obviously, when you get to big data sets or you get to process things like images or video, that's where you really need a load of grunt work. Actually, just sort of, thousands or tens of thousands of rows of just numbers, it will be pretty quick. But when you look at things like trying to get image recognition, that really takes a massive amount of grunt work. So there we go. We've built a model. We've trained it. We've run our test data through. We've got an accuracy of 99%. So it's an important thing it's an important conceptual thing to understand with machine learning, is that machines learn, and their learning is only as good as the data you've given them, and so they're trying to get more and more accurate based on the information you provide. It's a bit like when you've got a child and a child's learning to talk, and every now and again they use the wrong word, and you kind of say,
yeah,
oh, don't say free, say three, and all that sort of stuff. And then the next
wonder where
time
you're
you say
going
that,
there.
and then the next time they learn it and they do that bit right, but something else is still, and it's a gradual process of learning. But the point being that if you're writing a mathematical function, 1 + 1 = 2, you know that's going to be right. Whereas with machine learning, we're trying to get ever more accurate based on better data and better learning. So what we've done here anyway, we've created this model. We've got a reasonable accuracy. If we had much bigger data sets, we'd probably get that to be a lot better. And we've exported this model to our to a file, and it's just in here. It's a pickle file. That's just binary. It won't particularly mean anything if you were to look at it. But what we can do is we can actually test that model with some example data points. So what we've got here is just set up some sample input data. So if you had a program that was running the model, you could load this model now, because one of the things you see here is where we're actually importing the model from disk. So if that model was on disk, you could write a program that loads that model up. You then fire in some data at it, and it will tell you whether it's an anomaly or not. And that is actually running a machine learning model. So this isn't just a model we've used. This isn't just continuous from the model. This is a standalone bit of code. This is loading a model from disk into memory, and it's running it against some set of data, and then using that to predict whether that is good or bad. So what we have here are some example data points. So these ones here, the first ones, we know these are normal data. So these should say that the predicted class is 0. It's not an anomaly. These are good. So if I run that, then bing, there we go. The model has predicted that is not an anomaly. However, if I were to take one of these pieces of data at the end, then these ones, we're kind of expecting these to be an anomaly, because we're just cheated. We've looked at the test data. We know what's going to cause an anomaly. But yeah, we run that, and in this one, the predicted class is 1, so that is an anomaly. So we've created a, what we've done in this demo is we've taken some test data, we've created a machine learning model, and we've actually loaded it into a program and run it to give us an answer. And that is, for today, is just all we're going to demonstrate, but just how easy it is to build a machine learning model. So yeah, what are your thoughts immediately on that, Danny?
Firstly, how simple that really was. Obviously, using the cloud and using Azure and having the capabilities and the tools that allows you to use is fantastic. I think that was my initial thoughts, really. Like you say, having bigger test data will obviously show some sort of bigger predictions, if you like, and some better predictions in terms of our percentages. But yeah, real simple, straightforward.
Cool. So really, I mean, that's all we wanted to say for today. Is just really, this stuff is so accessible there is, get away from the hype of machine learning, get away from the hype of artificial intelligence. You can fire up an Azure subscription, fire up a machine learning workspace, and be doing this stuff in no time at all. It's not, it's not as scary as you think. So, we spend most of our time worrying about what problems we want to fix. But I just wanted to take this video just to tell everyone, look, in terms of actually writing the code and running these models, it's that easy. It's a handful of lines of code. So I hope that's been useful, and we will be back very soon with another demo. All right, thanks a lot.
Great stuff.
Bye
Thank
now.
you. Bye bye.